Assalamu alaikum. My name is Ayesha Akter. Now I am going to present a concept paper proposal presentation whose name is Natural Language Commands to a Robot Control System Automatically. This presentation is designed for Mr. Anajit Alim Russell sir, who is our Symbolic Machine Learning Part 2 course instructor, and the course code is CC712. Let's start from the next slide. This slide belongs to my concept paper. Here I have included the whole paper that have abstract introduction, related work, technical approach, dataset map, experiment, conclusion, as well as the reference part. From the next slide, I am going to explain every part that I have included in this paper. Here the abstract part. In abstract, action and control is structure that can be readily implemented by natural language commands to a robot execution system automatically. I have a plan to learn a parser based on example like English commands and corresponding control language expression. Next to the part is introduction. So here have natural language is a rich initiative mechanism by which humans can interact with systems around them, offering sufficient signal to support robot task planning. And my goal is to investigate whether it is possible to learn a parser that produces correct robot executable commands for such instruction. Now this slide have a related work. So parsing natural language to express formal representations such as lambda calculus has been demonstrated. Lambda calculus is able to represent complex robot control system. The next figure we are seeing this tasks going from NL to robot control. First, the natural language commands is parsed into a formal procedural description representing the intent of the person. Next, the robot control commands are then used by executor along with the local state of the world to control the robot, thereby grounding the NL commands into actions while exploring the environment. Next slide is bearing the technical approach. So what have? So my approach is to first natural language into high-level specification of robot behavior, which can then be executed in the context of an arbitrary environment. And the next picture we have seen the high-level architecture of the end-to-end system. Training is performed by learning a parser from English instructions to RCL. In the experimental phase, the learned parsers map NL instructions to an RCL program that is executed by the robot. And the next figure is bearing that the complete list of terms in robot control language. Here next slide is also a part of technical approaches. So importantly, UBL can learn a parser solely from training data of the form fxiziz, where xi is a natural language sentence and zi is a corresponding semantic language sentence. In this work, I want to use a new initialization that is better able to handle our semantic language. In section 4, bearing the data maps, language dataset were generated as the follow. First, English training and testing data from earlier work 1. Another paper, which belongs in reference sections, was re-annotated in RCL. In another paper, number 10 and 4, all English instructions are segmented into individual movement phrase. Next, experimental. In experimental section, I am interested in whether the robot reaches the desired destination by exactly following the described path, baseline, parser, as well as the route following experiment. Next, the last part is conclusion. So, this makes it possible to target a rich robot control language capable of handling abstract notions such as counting, loops, and conditionals. As an example, consider the different contextual appropriate interpretation of the word go, where the system learned to interpret go to and the go left as having quite different meanings. I want to establish that the help of parsing into a procedural language does require extension to the parser learning process. Last section in the presentation or paper presentation is references. Here some kinds of few references that I have used to create my concept paper presentations, and thanks to all, thank you.